Hello everyone and welcome back to another video. Up until now we have seen that everything on Linux runs on processes, and these processes behind the scenes take some CPU time, they take some memory, they take some resources, right? So in this video we are going to majorly talk about how these processes utilize the resources behind the scenes, the resource utilization, and we are also going to take a look about the logging that our system does. So this video is again a part of the Linux Masterclass course. The link to that playlist would be in the description below. So if you're new to this video, then do make sure to start from the very beginning, otherwise a lot of things might not make sense. And yeah, without any further ado, let's get started. So earlier when we were talking about processes, we came across a command which was known as top. Right, and this is very similar to PSOX or PSAUX, but instead of just giving us a snapshot of what your resource utilization the process is doing, this top gives us a updated version of it. It keeps getting updated. Maybe after every 5 to 10 seconds, it just updates what process at that particular point of time is taking how much resources. So let's quickly run this command in the terminal. I'll do a top, and we are very familiar with this output. We have seen this output before. We know what the PID is, we know what user is, we know the nice value and things like that. So we know a lot of things about this, but what we didn't discussed earlier when we were talking about processes was what is all of this stuff, like what actually is all of this stuff, right? These first 5 lines that are there, what does this mean, right? So let's start with this. And in the first line itself, you would see a lot of things that are mentioned here in the first line, right? So let's understand these values. So the first value that it tells us about is this number, this 418 and 22, which is continuously updating. 418 25, and now it would be 418 28. So this is the current time, right? The current time of the system. As you can see, I'm recording this video early in the morning at 4 a.m, right? So this is the time, like the current time of the system. Then secondly, we see this second number, and this is the time since which the system has been running. So currently it says that the system has been running since 9 hour 18 minutes, right? So that's what it tells. Then thirdly, it tells about how many users are currently logged in into the system. So currently me, Apoorv Goel, is the only user who is logged in into the system, so it just shows one user, right? And then this top line shows us about some values which are load averages, right? Like how much load the system is taking. And don't worry about these values yet. We are going to discuss these values, these load averages in some detail later on, right? But moving forward to the second line, the second line tells us about the tasks, right? Like what are the tasks that are currently going on. Again, this line is pretty self-explanatory. It simply tells us that the total number of processes or tasks currently is 309, out of which one is running, right? 308 tasks are sleeping or processes are sleeping. 0 of them are stopped and 0 of them are zombied. So we already talked about what zombie processes, what orphan processes are. We also now understand what mother processes are in a like in a lot more detail. So let's not talk about that. And moving on to the third line that it says, it simply says the percentage CPU that is there, right? The percentage CPU with some values here. So understanding about these values, the first one says this, this number and then US next to it, right? So this first number that is there, this one which is currently 1.5 and now it is 2.8. This says that currently it is using about 2.8 or 2.2 or whatever this number is, this much percentage of CPU time in running the user processes that are not niced, right? So the, like, by default, no processor is niced by default. They have a default nice value whenever we run a process, right? So this much percentage of CPU time it is consuming to run those user processes that are not niced, right? Similarly, if we go to the second value, it says that 0 0.1 and then sy. So sy stands for system. Currently it's 0.2. So it is utilizing this much percentage of CPU's time and running the processes that are meant for the system, or you could say the processes that are running by kernel, right? The kernel also runs some processes, right, to do the resource management and things like that. So all these processes, they are consuming 0.1 percentage of the CPU time represented by sy. Then we again see this 0.1 and then ni stands for the nice, right? So this is the percentage of CPU time that is spent in running the processes that are niced, right? That has some nice value. Then we have this 98.4 and then id, 96.1 and then id. So this id means that this much amount of CPU time is currently idle, right? So this much percentage of CPU time is currently idle, right? So that's what id is. Now our system is constantly looking for some input and some output, right? It might be getting some input through some network, it might be getting input from a user or things like that. Maybe we are entering something from our keyboard. Now to listen to these input streams and to give some output based on these input streams, CPU, our CPU or our kernel, let's say, assigns some percentage of CPU time into waiting CPU time, right? So this WA here simply means that this much percentage of CPU time currently is invested in waiting for the input output streams, right? So that's what the WA is. Then in our system, usually there are sometimes some hardware interrupts, there are sometimes some software interrupts, right? And our kernel needs to listen to these interrupts as well. If let's say we interrupt a software, or due to some complications our hardware interrupted something, right? So this HI and SI value simply means that this much percentage of CPU time is currently getting invested in the hardware interrupts and the software interrupts, right? So that's what HI and SI is, hardware interrupts and software interrupts. Then lastly we have this value, the 0 0.0 and then ST. ST simply means steal time, and like currently it's 0 0.0, in majority of the cases it is going to be 0 0.0. But if let's say you are currently using a VM or a virtual machine on your system, and inside that virtual machine you installed Ubuntu, then there is going to be some CPU time that your Ubuntu is utilizing, there is going to be some CPU time that Windows is utilizing. So this ST means that how much percentage of CPU time is something else stealing out of this operating system, right? So in that case Windows would be utilizing some CPU time, right? So that would come under the steal time of this much percentage of CPU time is the steal time currently, and this steal time would be used to run the processes that the Windows is running currently. Then finally we have the fourth as well as the fifth line, which is the MIB mem and MIB swap, right? So as the name suggests, MIB mem is for memory utilization, and MIB swap is for swap memory utilization, right? So it says that we have about this much MB of memory, 15,921, because I have 16 GB of memory in my system, right? Out of which about 10.5 GB is free, this much is being used, and this much is used for buffer or caching purposes, right? And it says the same stuff about the swap memory as well, how much is total, how much is free, how much is used, and things like that, right? So that's what it usually is. Now we see a lot of processes in front of us, right? We see, I mean, so many processes. This is 1909, there's 16514, 1636. There are so many processes that are running, but sometimes we only want to monitor just one or two process. Maybe we ran a system, maybe we ran an application in our system, and we feel that maybe that application is making our system slow. Maybe you opened a lot of tabs in Google Chrome and you feel that the Google Chrome is utilizing a lot of memory, or maybe some software, things like that. So in those scenarios we only want to monitor that one particular process that we suspect might be slowing down our system. So as we see that top gives us information about all the processes that are running, but what if we just want information about one process, right? So for that we have a special command, like we have a flag, I would say, which is top, and then after that I will add a hyphen p, and hyphen p stands for process id, and then I'll enter the process id that I want to monitor. I press enter here, and it will now only show me the memory utilization or the resource utilization, the CPU time and memory utilization of that one process whose PID I entered. So we know that the mother process that is there has a PID of 1, right, which is the most important process in our system. So I entered the PID of 1, right, and I can see that this time I only see this one process, which is not updating as such because our system is not doing anything. So now let's imagine a scenario, right? Let's say you have a pen drive, you have a USB, right, and you take that USB and plug it into your system, right? You did some stuff with the pen drive. Maybe you moved some data, you copied some data, you pasted some data, or maybe there are some files that you're trying to access. Maybe I have a code base in my pen drive and I'm like opening it through VS Code. Now I suddenly want to eject my pen drive, so I right click on the pen drive and I try to eject it. So sometimes it tells us that this device is currently in use, so you cannot eject it right now. And we might get confused because of that, because when we try to see, we see that everything is closed. I'm not accessing any of the files that are there in the pen drive. I closed my Visual Studio Code. I'm not accessing any code base in the pen drive. I don't have any image open that might be in the pen drive. So what does it mean that my device is in use? Why is it not letting me eject it? Now these files that we are talking about, if let's say they are in use, if let's say your device is in use, it means that any one of the files that are there in that particular device, in this case a pen drive or a USB, might be getting used by a process, right? Because everything is a process, right? Even the Visual Studio Code that I open to, let's say, access some code base is a process, right? Even some gallery software that I might have in my system to just view the images, if I open that, or some video player, that's a process, right? So we know that these files, some file in that device is getting accessed by a process. So to know what files are currently in use by a process, there is a command known as lsof. Right. This is simply, ls means list, o means of, f means files. So list of files, lsof, is a simple command which tells you, the list of all the files that are currently in use along with the associated process with them. So whatever process is using these files, they are going to get listed here along with the name of the file, right? I press enter here, and I can see that there are so many files, so many that I have to keep scrolling. I'll just scroll it once, right? And it doesn't like gives us anything per se, right? So what I'll do is I'll try to add it into an less, and so it tells us what command it is, it tells us the PID, it tells us what user it is, it tells us the type, right? It tells us a lot of things. So here we will know that what processes are utilizing what files or have opened what files, right? So this command can be very handy sometimes when you like want to figure out why you are not able to eject a particular device, right? Now whatever process is utilizing some file of your device, so you can simply kill that process with the kill command and eject your USB or your device and be over with it, right? Now let's talk a little bit about threads, right? So let's talk about threads. And if you're not a complete beginner, then you might have heard about some things that are known as threads. So let's try to understand what threads are. So let's say that you're playing a game, right? Let's say that this is a game, right? And this is a multiplayer game, right? So let's say you're playing this, and let's say this is a car racing multiple game, right? So there are going to be two cars, right? This is one car and this is the second car, right? Now you might be controlling this car, right? You might be controlling the first car, and some other player sitting somewhere out there might be controlling the second car, right? Now when you play this game, The second car, your car is automatically updating as per you're moving it, right? You're pressing the left arrow key, it is going left. You are pressing the right arrow key, it is going right, right? So your car, automatically moves as you are moving it through your keyboard or your controls. Now you see that whatever the second player is doing, no matter wherever he is sitting in the world, his movements are also getting reflected in your game, right? And your movements would be getting reflected in his game as well, right? So in this game there are two things happening at the same time, right? So the first thing that is happening is the game is updating, or the position of the player is updating, right? And the second thing that is happening is that the position of the player is sent to the internet, to some network, right? So these are two things happening. The first thing is that the position of the player is updating in front of you. Your position is updating based on whatever you are controlling. The second player's position is updating whatever he is controlling or she is controlling, wherever they are sitting, right? The second thing that is happening is that whatever you are controlling or whatever they are controlling, their position or your position is being sent over to some server, and that server is sending that position, like the second player's position, to your game. Your position is being sent to the other player's game. That's why you can see what movement he is doing or they are doing. That's why they can see what movements you are doing, right? So there are two things happening at once in this game. Now there are multiple ways to do this thing, to build this kind of functionality where whatever you are doing is being reflected in some other's game, and whatever they are doing is getting reflected in your game. There are multiple ways of doing this in the field of software engineering, because I mean, each and every problem, it's not like each and every problem only has one solution. There are multiple ways to solve a problem. So there are multiple ways of doing it, but the kernel provides a system to have multiple ways of execution in the same program, right? So to give you another example, let's say that you are writing some code in some editor, right? So you're writing that code, and whatever you write, after some time or when you're done writing, is automatically getting saved, right? You're writing and it is auto saving it, right? So in the example of an editor, right, you are editing and it might be auto saving. So these two things in some ways are happening at the same time. As soon as you are done editing, it is auto saving it. To think about it in terms of how a process works, I'll draw another diagram, right? And I'll again give the heading of threads, right? So let's say that this time this here is a process, right? It is a process. Now it has one bit of code that is doing something. Maybe it is updating your game, or it is helping you edit some code in your editor. And you have a second bit of code, right, which is sending whatever positions your car is in or your player is in. It is sending it to the server so that it can send it to the other player, or it is sending their information to you, right? Or it might be auto saving in the example of the editor that we took, right? So these two things that are there, they are simply multiple threads of execution, right? So they are simply multiple threads of execution. It's like, so inside the same process there might be two different bits of code that might be working parallelly, right? And they might be doing two different things, right? in the examples that we just saw above, in the first example, the first thread might be updating the position of the player or the car in our screen, and the second bit of code might be sending our data to the internet so that the other player can receive it, or their data on the internet so that we can receive it, right? In the second example that we saw, one bit of code might be accepting our input stream so that we are editing the file, and the second bit of code might be auto saving it as soon as we are done typing. So these are known as multiple threads of execution, and this is the system that is provided by the kernel inside our inside the system to achieve this kind of a functionality. So these threads are often known as lightweight processes, right? So the threads that we are talking about, they might also be known as lightweight processes. And there is a way of checking how many threads a process might be having in our system, right? So to check that, we have a very simple command called ps. Again, if you remember, ps is the one that we use to check all the processes that are there. And after that, if we add a simple -m or a simple m, right, and press enter, we can see all the processes that our system is currently running along with its threads, right? So we see that there is this one process which is basically the genome shell that we are running, right? It has these three processes that are there, right? We have this you know Ubuntu session running, again the binary of the genome session binary, right? And it again has three processes, since the above one has three processes, right? Then we have bash, right? And if you remember, then bash is the programming language that our shell runs on by default, right? So it is running the bash process with just one thread, because since we only have the bash running, it only has one thread right now, just the bash that is there, right? And then we have, like, currently we are running the psm command, right, to view this, and again that has just one thread which displays us this information. So all the threads that any process might be having, if you see that this is a process, right, this is a process, right, this is again a process, and this is again a process. So all of these are processes. All the threads are represented by two hyphens, right? The PID is a hyphen because since they are not individual processes, they are threads of a process. They don't have a unique process ID, right? They don't have a unique TTY associated to them. They don't have a terminal associated to them, right? So that's a hyphen. And when you see a hyphen and hyphen, that means that this is a thread of that process. So this genome shell and this genome shell's binary have three threads each. But after that, when we talk about the bash on, like, that our terminal is running currently, and the command that we just ran, psm, that only has one thread, right? That is not having multiple threads of execution right now. Now there is one more command, right, which is simply uptime, right? So if you remember this uptime, like, if you look at this, you might see that this is like resembling very much with the first line that we saw in the top command, right? So we can say that whenever we run the top command, the first line that is there is simply the output of the uptime command, right? And we know that this is the current time of the system, 4:58, almost 5 in the morning, right? This is the time since which my system has been running, right? It is currently logged in by only one user. And then we have these load averages, right? So what does this load average mean? What I'll do is I'll simply copy this, right, and I'll paste it here. Right, so we see something like this. This is the load average that we kind of see. We saw it in the top as well, and we also are now seeing it in the uptime command as well. So what does this load average mean? Right, what does this mean? Now this load average is a very good way of seeing the load on your CPU in your system. And this load average simply means that how much load is there on your system at the interval of 1 minute, at the interval of 5 minutes and at the interval of 15 minutes. Right. So it simply tells you, like, after intervals of 1 minute, 5 minutes and 15 minutes, like in this order, how much load is there on your system. And when I talk about, how much load is there or how much, CPU load is there, so this question mark is how much CPU load, right? And when we talk about the CPU load, what does the CPU load mean? This means the average number of processes waiting to be waiting to be executed by the CPU, right? So load averages mean how much CPU load is there at the intervals of 1 minute, 5 minutes and 15 minutes, and CPU load in general means that how many average number of processes are there that are waiting to be executed by the CPU. Now to give you a very simple example, let's say that you have a 1 core CPU, right? And let's say that this 1 core CPU is simply a lane, like a road, right, with the, a lot of traffic inside of it. Now let's assume that this road is very busy, right? There might be some rush hour or, something like that, and this road is very busy and it has a lot of traffic. So we can say that at that time the CPU load is 1, right? If let's say the traffic is even more, it's more than, it's double the amount that the road can handle at once, right? Then we can say that the CPU load in this case is 2. Similarly, if let's say this road can handle 10 cars at once but 5 cars are there, then we can say that the CPU load is 0.5. Right. And if let's say there is no traffic at this road at all, or very less traffic, maybe it's night time or something, right? Then we can say that the CPU load is very less. Not 0 exactly, because that can't be. There are, some processes always running in the system that are running the system, right? So it won't be 0, but it would be very less. Now, one thing to observe here is that a load of 1 doesn't mean that your CPU is like performing very slow right now, because most of the computers in today's time do not come with a single core CPU, right? So on the other hand, if we talk about a 4 core CPU, right, then you can imagine that that would be almost having about 4 such lanes, right, with some traffic and all of them. And if in this scenario, if the CPU load is 1, then that simply means 25% of CPU is getting used, right? Because this time it can handle 4 times the traffic that it like would be able to handle with just one lane, right? So 4 core CPU, if the CPU load is 1 and you have 4 cores in your CPU, then that simply means that the CPU load is 1/4 of whatever number it is showing you. That means 25% in this case, right? I also mentioned this in my processes video that if your CPU has multiple cores, then it can handle, multiple processes simultaneously. And then someone asked me in the comment section that what if, these cores or the CPU cores that we are talking about can handle multiple threads at the same time, right? So since they can handle multiple threads, and as we discussed earlier, threads are, just simply known as lightweight processes, and different processes might have multiple threads of execution. I would leave it to you. What do you think if your CPU has 4 cores and each of that core can handle 2 threads each, right? Then how many processes can it execute at the same time? Just think about it, pause this video, try to answer it. It's pretty straightforward, right? It would be able to handle 8 processes at that time because it has 4 processes, so it can like handle 4 processes obviously. But since it all these cores can handle 2 threads at once, then that means that they can somewhat handle 2 lightweight processes or 2 processes at once, right? They can do things like they can have multiple threads of execution. What are these threads? They are simply multiple uh, channels of executing it, right? Or multiple resources of executing it in terms of CPU. So if your CPU has 2 threads in each core and you have 4 cores, then you can execute 8 processes simultaneously. If you had 8 cores and 2 threads each, then you can process 16, you can handle 16 processes simultaneously, right? So that's all about the load averages that we were talking about. Now there is another command known as vmstat, which gives you a detailed version about how much memory your system is utilizing right now. So R usually means how many processes are there in runtime, B means how many processes are there in uninterruptible sleep, how many swapped memory we have, right? How many free we have, how many is there for buffer, how many is there for caching. It says how many memory is swapped in from disk, how many memory is swapped out of the disk. It also tells us how many blocks are received from a block device, how many blocks are sent out of a block device. It tells us how many interrupts are there, per second. The CS stands for how many context switches are there per second, right? So how many processes it is giving time to in 1 second. This is simply CS, and the value of this is pretty high. It is about 50. So it usually means that it is currently switching context 50 times in a single second, right? Executing 50 processes per second. Then it is simply how much time is used for user, for system, how much is idle, how much is for waiting for input output streams, the WA, and then ST is the steal time, how much time is going for in the steal time and things like that. So this is that tells you a little bit about everything that is there. You can also see this uh, the categorization above it. These are for processes, this is for memory, for swap, for input output streams, for the system itself, how many interrupts per second and context switches per second, and then some data about the CPU. Now let's talk about something else, right? I think that that's pretty much it for how much resources are being utilized, like by the processes that are running on the system. But there is one more thing that our system does, and that is known as logging, right? So we know that a lot of things are running in the system. There are some kernel processes, there are daemon processes, the mother process, and all of these processes are like continuously doing something in our system. Now all of these things that are happening, all of the events that are happening in our system, they all of these events are being saved in a file, right, in a human readable format, and these files are simply known as log, right? So these files are simply known as logs, and this process of these like this thing of these processes and whatever is happening in our system getting saved somewhere, all these events getting saved somewhere in some files known as logs, is known as logging. Now all of this data, if you remember from one of the previous videos, all of these logs and stuff are saved in what directory? They are saved in /var directory, which saves all the variable data. Now, how is this happening? Right, I mean, there are so many processes running, the kernel is doing so many things, there are daemon processes that are running, and so much things happening in our system at the same time. So, what is creating these logs? How are these logs getting created? So, all of this is done through a service known as Syslog. Right. So there is a service known as Syslog, that collects all of this information, whatever is happening in our system, and sends it to something that is known as a system logger. Right. Now, one of the most important components of this service syslog is a daemon known as syslog d. Right. And this daemon, this syslog d, as the name suggests, it's the daemon for the syslog service. Right. So this syslog d daemon, it simply just waits for event to happen. Right. It just waits around, and as soon as some event happens, it tries to figure out what does it needs to do with it. It might be that it needs to send it to a file. It might be that it needs to print that message into the console. Right, there could be a lot of things that are happening with these messages. Right, so this is the most important component that is there for the syslog service. It might also be that it doesn't wants to do anything, like we saw that slash dev slash null, which just nullifies whatever we get as an output. It might be that it doesn't want to do anything with that message. Right, it's completely useless. Now in software development, when we develop applications or whatever applications we have in our system, all of these applications, they might have some different mechanism for logging whatever is happening inside of them. And this logging is one of the most critical aspects of software development, because we as software engineers need to understand what users are doing what at what time. And you know just to understand that if, let's say, later on in time, if a bug gets created or something like that in a huge system, in a large system, then we need to understand what might have possibly triggered that bug. Right, we need to understand what our system was doing when that bug was created, just so that we can understand how it might have caused. Right, so all of these applications, they might have some different mechanisms of logging their information, and generally these logs only contain some timestamps along with the event itself. Right, some details about the event. Right, so whatever events that are happening in our system currently gets logged in a file, right, which is simply I can do a cat and then a slash var, right, slash log and then slash syslog. Right, so this is the file in which all the events are logged, and I'll view this in a less command. Right, so I can see that all of these you know these are the latest events that were logged, and they are being stored along with time. So I can see that as soon my system turned on, I see a lot of things, and I like don't want to see all of it. So what I am going to do is I'm going to remove this less and use a simple tail. uh, Use a simple tail. Right, so now I can see that currently it's about 5:18 in the morning, and this discord message was the last message that the system logged. Right, so this is the stuff that has been happening in my system in the last, like, these are the last 10 entries of what is happening in my system. Now again, this all of this happens through the service known as syslog, which sends all the information to this system logger. Right, and it simply logs it into a file which is known as we saw, slash var slash log slash syslog. Right, so all of these files, the system logger saves it here or logs it here. Now this is not the only file that is maintained by our system logger. Right, so to find out what files are managed by the system logger itself, we can simply check out slash etc and slash rsyslog.d. Right, so there we can see that there are these config files. Right, I can simply do a 50 default one. I can check this out and I can see that there are going to be all of these files that are logged by my system. Right, so we can see that there is a file known as kern, maybe for some kernel logs, for some mail logs, right, for some mail errors. There is one file. All of these are commented by hashtag mostly, but these are the files that are there. Right, and similarly there was one another file which was 20 and then ufw.conf. So again, inside this we can see that yeah, this contains something known as ufw.log, right? And this is the log kernel generated ufw log messages to file, right? So all of this is there. Now you can also send some messages manually into your logs, right? So sometimes, we might have done something and we just quickly want to document that into the logs, or save some keyword into the logs so that we know that after which keyword do we want to start searching in the logs. Maybe we are about to do something that we know for sure is going to break something, right? So in that case we might want to save something, some message to the log, so that when we go back to those logs we can quickly search that message, and after that, right after that, we can start seeing what our system did. So I have a command, simple command for this known as logger, right? And I can add a hyphen s there, and then I can write a very simple message like please subscribe to this channel, right? I wrote a very simple message, right? I pressed enter. Again, I can add more things, right? Like please like this video, right? I can write as many logs as I want, and then if I again try to tail it, like slash var and then slash log and then slash syslog. If I tail it, I can see that this time in this file, or I shouldn't have added a tail, right? I think it went a bit above, right? But let's say we do a tail and then 100 hyphen n is and then 100, so it will show us the last 100 lines. And here we can see the messages that I typed, right? It says that on June 7 at 5:22 in the morning, it says that please subscribe to this channel, and then after some logs, maybe my Discord is doing something in the system, but then it says that please like this video. So my logs are saved in this system. I just created some logs, manually entered them into my syslog file, and these can be used to just make sure that whatever you do after this you can quickly find that up, right? Just like I was able to find my message and I can see whatever happened in my system. The Discord is, I don't know what it is doing, but never mind, right? So that was about how you can log it into your system. Now there are a lot of log files that you can view in your system, and generally they are all located in the same location, slash var slash log. Here if I press tab a couple of times, I can see that there are a lot of files that are there. Kern.log that we were seeing there, then we have the syslog file itself. We have some logs for Zorb, which the Ubuntu uses, and we have all of these different logs. We have a lot of logs for booting and authentication as well, and generally this syslog is more than enough to um just understand what is happening in your system, right? So this syslog itself is more than enough. There is also one more log file that is known as dmesg, which is t message or something, right? I If I, let's say, do a cat in this one, then I can see that again it is giving a lot of logs to me, right? And these are the logs that are per se not very essential for debugging purposes, right? But this more or less logs everything that our daemon processes, our kernel, and all of these internal things are doing in our system. So they are all logged in this d message log. Now how are these log files managed? They are taking so much data, right? And they are saving all this data in some files, so they must be utilizing some space on our disk. And most of the times when we want to check logs, we only want to check the latest logs that are happening, and we are not very concerned about what happened 1 month from now. It also has to manage all the disk space efficiently, since it is taking up so much information. We need to make sure that it is efficient in how it manages this space. Now all of this management that is there can be done through something which is known as a log rotate. This log rotate utility does the log management for us. Again, just like any other process or application that we have, even this Logrotate utility has a config file in which we can, specify what logs we want to keep, and how do we want to compress our logs and things like that, right? So we can manage a lot of stuff, configure a lot of stuff through, the config file of this Logrotate utility. Now this Logrotate, runs every day through something that are known as cron. You must have heard a lot about cron jobs, right? And cron is something that we are going to learn about sometime later, when we have some practical use about cron, most probably when we are, dealing with Python or AWS or something like that. This log rotate, runs every day through cron jobs. It is configured in cron. Now the config file that we are talking about, again, I mean, all the configs are there in the /etc folder, so we can find it in /etc and then /log rotate.d, right? Inside this we can see that there are, so many different things that are there. All the configs are available here for different types of stuff, for boot logs, for apt logs, for depackaging logs, for syslogs, for different types of things that are there, right? For daemon processes and things like that. Now there are a lot of, tools to manage these logs, but this log rotate is the most common one, right? So I think that's pretty much it for this video. In this video, we talked about process utilization, how it utilizes resources, how we can check, how much resources they are utilizing, how much CPU time, how much memory. We also discussed about what processes and their threads are, and how, a process can have multiple threads of execution. And finally, we took a look about logging, right? So with this, I think it's time to bring an end to this video. Now I'm sure that again you must have learned a lot of new things in this video, and all of these things in some point of time are going to come in handy for you. They are going to help you big time, right? Because I mean, for me, whatever I've taught you so far, all this knowledge, the one thing that it has done for me is that it has made me more and more curious about software engineering as a whole. Because after understanding all of these things, I always feel whenever I'm, using some application or I'm building something, I kind of always feel that deep down there is, a reason why this is happening this way. So it has, made me ask a lot of whys in my career, right? Just like learning a little bit deep into, just diving a little bit deep into Linux has enabled me to ask a lot of whys in my life. And it has enabled me to find the reasons of how things are working internally, and how, things usually work, and how they should work, and how to design good systems. Because operating system is like one of the best, systems that we have, one of the best softwares that we have, that, runs all the softwares that we build on top of it, right? So it has made me curious in a sense, which is very important, when you, especially if you are a software engineer. So I'm sure it taught you a lot of things, and going forward it will spark that curiosity inside of you, of asking those whys, like why does this work this way, and how does this work internally, and getting into the depth and roots of it. Because that is what is going to make you a great software engineer, and that is going to help you in, debugging any bugs that you may encounter later on in your life, when you are working on big applications and things like that. So whatever you learned in this video, do make sure to write a nice blog about it. Do make sure to write a Twitter thread about it if you don't want to write a blog, right? The best ones, the best blogs and the best Twitter threads would be featured in the virtual tech schools video. And whenever you post a blog or a thread, do use this hashtag learning with Apoorv, right? Tag me in those tweets, right? Whenever you're tweeting it in public, or if you're, sharing it on LinkedIn, if you're posting about it, on LinkedIn, then find me on LinkedIn and tag me in LinkedIn as well, right? And just make sure to keep learning in public. Make sure to ask in public, not just learn in public. You should also, build a habit of asking in public. If you have any doubts or anything, make sure to use our Discord server. If you haven't joined that yet, then do make sure to join that. The link to that would be in the description below. uh, join that server, use that server to ask questions from the community. We have a very active community at Virtual Tech School, so I'm sure there are going to be a lot of folks who would be eager to help you. And yeah, I mean, with all of that being said, I think that's pretty much for this video. Don't forget to use hashtag learning with Apoorv wherever you're posting, wherever you're carrying out your learning in public initiative. And I'll see you in the next video. Till then, peace.